Всем привет! Стрим начинается. Сегодня 85-й день того, как я стримлю. Сейчас я секундочку кое-что сделаю. Мне нужно кое-что проверить. Сегодняшний стрим будет быстрым. Вряд ли буду я затягивать его. Все. Еще раз всем привет. Мы начинаем. А как сделать на полный экран? Не совсем понимаю, как сделать полный экран. Секунду. Ctrl-Command-F. Вот и все. Готово. Мы переходим к графам. У нас тут вторая часть Course Schedule 2. У нас время сжатое, поэтому мы сегодня будем поступать так же, как вчера. Мы буквально включим решение сразу и по нему сделаем то, что нам нужно.
Welcome back, and let's write some more NeetCode today. So today let's solve course schedule 2. And if you haven't already seen, I've actually solved the first one, which I recommend watching that video or at least solving that problem before you try to solve this one. It's a little bit more difficult, but it's also very similar. So we are again given n courses labeled from 0 to n-1, and these are basically going to be the nodes in our graphs. So this is a graph problem. And again, some courses have prerequisites. So course A has a prerequisite of course B. And what that means is you have to take course B before you take course A. So that's pretty intuitive, right? And so instead of knowing if we can take every single course, in this problem, we want to know for all of the courses and all of the prerequisites that were given, we want to return the order of courses that we would take in order to finish all the courses. So we care about the order, but there's one little subtlety. It's possible that we can't take all courses given the prerequisites. So if it's not possible, we have to return an empty array. So we have to determine if it's even possible, and then we have to return the order. So this example is pretty simple. We're given two courses, 0 and 1, and the prerequisite is, so in order to take course 1, we have to first take course 0. So then in that case, what's the order? Of course, we have to take 0 first and then course 1. So the output is going to be 0, 1, which is exactly what we have over here. Now, what if I added one more prerequisite? So what if I said, okay, to take course 0, we are required to take course 1 as well. What does that mean? That means, okay, the first prereq tells us that to take course 1, we have to take course 0. And the second one tells us to take course 0, we have to take course 1. Now, look at this. Is it possible to take these courses? It's not. To take course 0, we have to take course 1. To take course 1, we have to take course 0. There's no valid order, so we return an empty array. And we know to return an empty array because we have a cycle in this graph, right? There's a cycle that tells us that it's not possible. So now let's actually look at the general algorithm for it, and it's actually topological sort. This is a standard graph algorithm, but you actually don't even need to know what this algorithm is when you solve this problem. This problem actually teaches you what topological sort is. So similar to course schedule 1, what we're gonna do is starting at every single node, we're gonna run depth first search on the node. So let's start at node 0. Let's run depth first search on it. To do that, before we do that, we would need to build an adjacency list. So for each node, we would need to know its neighbors. So for course 0, we would need its neighbors, which are going to be 1 and 2. Basically, its prerequisites, right? That's going to be the prereq map. So it's an adjacency list. So I'm just going to quickly write that down. So now we have our prereq map, right? It tells us for each node, what are the prerequisites. So 0, right, has 2 prerequisites, 1 and 2, because it has 2 outgoing edges to 1 and 2. 1 has a single prerequisite, 3. 2 has no prerequisites, right? Because look, it has 2 incoming edges, but it does not have any outgoing edges, so it does not have any prerequisites. 3 has a single prerequisite of 2. 4 has a single prerequisite of 0, and 5 also has a single prerequisite of 0. And so we are going to build the output. We're going to do depth first search starting at every single node. And remember, the output we're trying to build is the order in which we can take courses. So just by looking at it, you can tell, okay, 0 has 2 prerequisites, 1 and 2. So of course, we're going to need to take 1 and 2 before we end up taking 0. But let me show you the algorithm. So let's start at 0. We don't update our output yet. We want to take the prerequisites first. So let's go to one of the prerequisites, by which we can tell from our prereq map. So we're going to be at node 1 right now. And 1 has a single prerequisite, 3. So we're going to need to take the prereq before we can take course 3. And now we see 3 has a prereq of 2, a single prereq. So all we have to do is take course 2 before we take 3. So now we are at course 2, and lovely that it does not have any prerequisites. What does that mean for us? So far we've taken a path. We've gone from 0 to 1 to 3 all the way to 2, and now we don't have any more prereqs. So we are allowed to take course 2, right? It does not have any prereqs. We can add it to our output. So I'm going to add a 2 to our output. And so what I'm going to do now is cross out 2 because we never have to visit it again, because once we've added 2 to our output, we don't want to add 2 twice, right? There's no need to add a course to our output twice. So I'm going to cross it out so we are never going to visit this node again. And now I'm going to, in our depth first search, I'm going to go back to where we came from. We came from this 3. So now that 3, look, 3 does not have any more prereqs, right? We've already visited 2. It doesn't have any more prereqs. So we can also cross it out. We never have to visit it again, and we add it to our output. And I'm just going to repeat this process all the way along our green path that we just went along. So we're going to go back to 1. 1, we just visited 3. We are never going to visit it. And 1 has no prerequisites anymore, so we can add this to our output. And we go all the way back to 0. Now, hold on a second. So look, 0 has 2 prerequisites, 1, and we already visited 1, but it has one more prereq, 2. So let's go to 2, but we see, right, we already visited it. We don't have to do it again. We can cross this out. So in reality, 0 does not have any prerequisites remaining. So what do? We add 0 to our output. Now, in reality, our algorithm is going to say, okay, we ran depth first search on 0. So now we're going to run depth first search on 1. But we know that we already did that, right? We already recursively did that, so we don't have to do it. And actually, before I forget, since we added 0 to our output, let's cross it out. So we ran depth first search on 0. We're going to try to run depth first search on 1, but we know we already did that. We're going to try to run depth first search on 2, but we know that we already did that. We're going to try to run depth first search on 3, but we know that we already did that. So now we're going to try to run depth first search on 4, which we haven't visited yet. And let's just use our common sense. From just looking at the graph, we can see that, okay, we need to take these courses in this order, 2, 3, 1, 0. What about 4 and 5? Technically, they both have a single prerequisite of 0, right? So once we take 0, we can take 4 and 5, but we can do it in any order, right? We can take 4, 5, or we can take 5, 4. It doesn't matter because these courses aren't a prerequisite of each other. But the way our algorithm is going to work, we are going to start in order. So we're going to go at 4. We're going to see it has a single prerequisite of 0, right? We can see that in our prereq map, and we know that we already took course 2, so we can also say, okay, course 4 has also been taken. We've done the prerequisites. We can take course 4. And we're going to do the exact same thing with 5 now. We're going to try to see, okay, it has a single prereq, 0. We've already done that. So now we're allowed to take course 5. So this is the topological sort of this graph. And we know that the topological sort is not necessarily unique, right? Like this could have been a 5 and a 4. So it's not unique. And we also know that if we detect any cycles, we have to return an empty list because that means that a topological sort is not even possible. And by the way, since we are visiting every single node and every single vertex, or rather every single edge, right? We have to travel along every single edge, I think at least twice, and we're probably going to visit every single node up to 2 times. So it is going to be so the time complexity is going to be the number of edges plus the number of vertices, or by vertices, we also mean nodes. So we could also write this as O of P, where P is the number of prerequisites, which is actually the number of edges, and plus N, where N is the number of courses, which is also equal to the number of vertices. And one last thing, how would we actually detect a cycle, like with our algorithm? Well, let's say we had a cycle. So let's say 2 actually did have an outgoing node and it had a node all the way to 0. In that case, what our algorithm would do is, okay, we're starting at 0, we're going to go to 1 just like we did previously, then we're going to go to 3 just like we did previously, then we're going to go to 2 just like we did previously, and then lastly, starting at 2, we're going to go to its only outgoing edge, which is at 0. And at that point, what our algorithm is going to do is it's going to see, okay, we started at 0, we remember that, this is the path that we've taken, we went all the way around and we landed back at 0, so this means we have a cycle. That means we stop our algorithm immediately and return an empty list. We do not have to continue. And the way I'm going to handle this is I'm going to use a hash set, and with that hash set I'm going to basically remember our current path, so we know, we can recognize when we detect a cycle.
Так, ну вроде как понятно. Так, что тут происходит? Стой. What the fuck? Алло? Слышно, да? Ладно. Странные. Лайки поставили. Все, давайте писать код теперь. В принципе, понятная задача. Ее в ТикТоке задают, в Гугле и в Apple задают. Нам нужен словарь сначала. Хэшмапа нужна нам. Course pre-rec, да? Пусть будет course pre просто. Мы создадим. О, блин, что я делаю? Сегодня немножко молчаливый стрим будет. Братскер. Да, я как-то уже 85 дней уже комментировал свой код. Мне сейчас немножко хочется помолчать. Не знаю. Ну, усталость некая накопилась за это 85 дней. Поэтому excuse me. Завтра, возможно, накоплю силы и буду уже общаться и буду жизнерадостным. В принципе, вот эту вот структуру я уже вчера объяснял, позавчера объяснял. Немножко подустал это делать. Ты за 85 дней до 210 дошел? На самом деле нет. Вот мой roadmap. 80-я задача. Помимо него были другие задачи. «130 задач у меня решено. Ежедневно он решается. «134 задачи за 84 дня. Слава богу, все работает. У тебя медиум много. Да, это из-за того, что я загнал себя в рамки и делаю исключительно по роудмапу и каждый день. Задавайте вопросы. Сейчас уже примерно буду уходить. Сегодня такой стрим шепчущий. тебя меньше? Да, бывает. Мне уже надоели алгоритмы, если честно. Уже тошнит от них, хочу уже забыть про них и этот вообще никогда не знать их. Не было бы стримов, давно забросил бы. В принципе, не вижу смысла дальше учить. Но там у меня есть еще динамическое программирование, я там ничего не знаю. Да, геометрия всякая, там тоже ничего не знаю. Вот их надо делать. А вот DFS, вот это вот графы, уже устал от них. You know? Вопросов нет, завтра посмотрю. 222 easy. Python. Ну, я тоже на Python не начинал. Потом JS подключил. Не сравнивай свою середину, ну, то есть свое начало с чужой серединой. Мы люди разные. Иногда я думаю, что я сумасшедший. Так, все. Ладно, до следующего раза, да, действительно. На этом мы с вами прощаемся. Если нет вопросов, заходите в телеграм-канал. Кто есть еще здесь, кто тут. Могу вам показать. Смотрите, у меня есть телеграм-канал. Здесь есть все решения, в том числе и сегодняшнее. Здесь очень много решений, конечно же. Очень все тут есть. Даже есть всякие опросники. Можете заходить, смотреть. Все для вас, в общем-то. А сейчас я с вами прощаюсь. Я, правда, очень устал. И никому не советую такие челленджи делать. Каждый день что-то учить. Ну, это безумие. Вот. Всем пока.